Hello, hello, sound check, just checking the sound. Hello, hello, sound check, just checking the sound. Oh. Sound check. Oh. Sound check. Are we getting any sound? I don't seem to be receiving any at this end. Sound check. Sound! Are we getting any sound? I don't seem to be receiving any at this end. Sound! Are we getting any sound? I don't seem to be receiving any at this end. Yep, I think our sound's good. Okay, I think we're all sounds good. Okay, let's get ready to start. Oops, that wasn't what I wanted to do. Okay, so here we are. Maurieo Maths IRL episode 2 is about to start. Okay, let's just clear the deck. Delete, and we're underway. Yes, sir. Okay, it's 7 p.m. and episode 2 is now starting. I think everything's going okay. Sound's coming out from here, and yes, I believe everything's all good, so that's fine. Just a little bit of an explanation as to what you're seeing on the screen there. The white sheet of paper, that is my tablet, and so I'm able to write on the tablet with my S Pen, and that's where we can do the mathematics. To the right of that is my phone, and that's enables us to access various apps on the phone. For instance, I could that would give me my calculator, which I have on my phone, so I can use a calculator, and also can access things such as ChatGPT, Photo Maths, any other little apps and things that might deem relevant to the topic. Now, the whole basis of the whole thing really is that it's live, and so people can engage. So we're after engagement. So although I will video what's going on here, and that will be available on my channel, it's really the live interaction that, you know, is what I'm looking for. So, you know, we'll have to see how that goes. So tonight, just while I'm sort of going, rambling along, let's just have a look at the topic of algebra, which is a lot of people get ALGEBRA, algebra. Now a lot of people get quite, oh, algebra, I've only just understood numbers, and now you're introducing me to letters. Well, algebra is a way, it's a shorthand. It's a way of doing things way more quickly. You know, we could say, for instance, you know, well, we do shorthand anyway, but if we go right back to our first principles, we can say 3 plus 5 like equals, and then we could say that equals 1, 2, 3, 4, 5 equals 8. And so we use numbers. We put a number in, 3 plus 5 equals 8. So we put numbers in. So we're doing that little shorthand, so we can go right back. Now, with algebra, of course, it gives us various sort of little shortcuts and things like that, and the ability to do things you know, easily. Now there, like for instance there, we've used a very simple example of numbers, but what happens if we start going to 3.076 plus 5.712, and then, well, that starts getting a bit more complex, doesn't it? And it's not as easy to do it that way. And so if we look at algebra, it gives us this ability to simplify things, provided we follow the various rules. And so it's a very simple sort of thing. We put a letter in, you know, in place of a number, and then we can go forward with things like, say for instance, if we want to multiply 3 times any 3 times 9, that equals 27. 3 nines are 27. But then if we want to multiply 3 times 10, you know, 3 times 10 equals 30. But if we want to multiply any number by 3, we can write that in algebra, and we can say, right, 3a, let a equal the number, 3a equals, and it's equal to a plus a plus a. Okay, so maybe I can fix that explanation. That's not quite exactly how I wanted it to go. So I'm evolving with these things as we go along. So if we say 3 times 9, so that's 3 times 9, that is actually, I'll put that in here as well. It is actually, we can say 3 times 9 is 9 plus 9 plus 9, which equals 27. Okay? And 3 times 10 is 10 plus 10 plus 10, which equals 30. So if we write it as 3a, it's a plus a, and equal to 3a. So, you know, that's an additive thing. So, but then if we go and say, right, I want to multiply 3 times 3 times 3, or maybe 3 times 3 times 3, right, well that also equals 27, but that equals a cubed, a times a times a. So we can represent things like concepts, and the beauty of this is that that applies for any number. We know that that rule will apply for any number. So we can say, you know, if let's see, 3a equals, let's say 3a equals 108. 3a equals 108. So we're able to say, well, let's have a look at what 3 times a is 108. So a number plus a number plus a number as 108, and it's the same number. Now, we can work that out quite easily because what we do in algebra is we just put a line underneath it and we divide both sides by 3. So if we've got 3 a's and we divide it by 3, we'll get a. We'll get 1a, won't we? You see, 3 a's, divide it by 3, we'll get 1a. Right, and the way we can show that is that we can what we see, because they're above each other, we can what we can say is, well, if we divide that 3 into that 3, that's 1. Any number divided by itself is 1. Okay, little rule, any number divided by itself is 1. So that just leaves a. So now we can say, well, hang on, well, a, oh, no, we wanted it to be that colour. What's going on here? I'm having a bit of a problem with my pen. That's better, and let's that. So then we can say a equals 3 divided by 108. Ooh, 3 divided by 108. Ooh, that's going to be that's a little bit tricky. Well, we might know. I reckon the answer's 3. I reckon the answer's 3 goes into 10. 3 3s are 9, 3 6s are 18. A equals 36. But not everybody's, you know, able to do that. So, okay, what we can do here is get out our calculator and just check it out. So 108 divided by 3 equals 36. Okay, 36. There it is. So, you know, this is some of the things. I'm trying to make algebra as simple and logical as I can. Now, I also said that we could have a cubed, a to the power of 3. Let's say that equals 125. 125. A to the power of 3 equals 125. Whoa, so that means, well, what that means is that A times A times A equals 125. Okay, and yeah, how do we go with that? What can we determine from that? I don't know. No, it's not helpful. Now, there's a thing called the cubed root. I think in this case, only in this case, A equals 5. So we can go 5 times 5 times 5. So 5 times 5 is 25. 25 by 5 is 125. Now, all right, and here we've got all sorts of little things. So here we've got A equals 36. So in the case where 3A equals 108, in that case, A equals 36. But if A cubed equals 125, in that case, A equals 5. Now that can be a little confusing for some, but it depends on the equation. So much to look at here. First of all, let's just have a look at this. A cubed equals 125. So how do we undo that? Or how do we find out what A is? Well, very simply, we find this thing called the cubed root. So what number multiplied by itself and then multiplied by itself 3 times equals 125? Well, there's another saying that we say, what you do to one side, you must do to the other. So equation. Think of the word equation, and then you think of a balance, a spring balance. Equation, equal. So, you know, if you're on a balance or a seesaw, and it's perfectly balanced, let's say there's 2 little kids on each end of the seesaw, they all weigh around about the same, so it's perfectly balanced. One gets off, it gets out of balance. So if one gets off one end and one gets off the other end, it stays in balance. So what you do to one end, you must do to the other. And so it is, if you take the cubed root of one side of the equation, I'm saying equation, or the seesaw, or whatever you want to call it, teeter-totter. So what you do to one, you must do to the other. So this cubed root, now that can be a little tricky on each calculator, but if we key in 125 here, 125, and I've got a button here, x cubed root y, so I'm going to push that, shift cubed root, maybe I'll clear this. So I think I need to push it first. We need to work shift, oh no, that's square root, golly, shift, there. Oh, no, that's not. How do we work this? Shift. Oh no. Doesn't want to. Okay, so we're going to go 1, 2, 5. This is it. Shift cubed root 3. Oh no. Oh, okay. Clear. I see it now. 3. Shift cubed root 125. And you can see that equals 5. Eventually, we got there. Sometimes the road is not so easy. Now, let's, so there we've got, in the case of the 3a there, we just divide. We've got 3 times a equals 108, a equals 36. Here we've got a times a times a cubed, 125, and we take the cubed root and we get 5, and we can do that on our calculator. But let's not forget, if we're a little bit unsure, we can use other things, like we could use ChatGPT, and we could say, if 3a equals 108, what does a equal? And we can put that in there. A equals 36, and it does it for us. So this is a good way of just checking ourselves, but also we can use that once we've learned something. We can use that to practice what we've learned. You know. So let's say. I could say, can you give me another similar problem so that I can practice to see whether I have got it correct? Maybe you could give me the problem and then wait for my answer and comment on the answer that I have given. Please guide me with this. Okay, so here's a practice problem. Okay, if 5b equals 145, what is b? Take your time to work it out and send me your answer. I'll check it and guide you from there. Okay, so let's see what we've got there is 5b. 5b equals 145. So what I'm going to do is divide both sides by 5. That's my thing. And so I know that the 5s, that'll cancel out the 5. And so b equals 145 divided by 5. So 5 into 14 is 2. with 4 remainder. That's how I do it. 5 into 45 is 9. Okay, so B equals 29. Nice work. Let's check it. Yes, and it tells you. And it gives you a little bit of encouragement as well. It says correct. You've nailed it. B equals 29. Want to try another one? We'll go a bit trickier next. Let's try another one, but let's see what happens if we get it wrong. Let's make a mistake. Let's fool it and see if we can make a mistake. Get it wrong. Yeah. Okay. All right. Are you ready? Let's go. Yes. Another. Okay, 7C equals 112. Okay, so let's see what we've got here. 7C equals 112. Divide both sides by 7. Some people actually write what they've done so that someone following up, you know, like checking their work. So you might put, I'd sometimes do this, you know, divide both sides by 7. Okay, so let's see. So then the 7s cancel out, or 7 divided by 7 is 1. Sometimes people put a little 1 up there, a 1 there. Yeah, it's you know, you get it as you do more and get more experience, you get quicker and quicker. So let's just say we make a mistake. Let's say it's 26. C equals 26. So I'm just going to put 26 here. Now I know that's wrong because we can see that 7 times 20 is 140. So yeah, so I just put 26. Close, but let's double check it together. So encouraging, but not, you know, very good. Let's double check it. So the correct answer is 16. Yeah. So you could go back and see where you went wrong. I said 7 goes into 11 twice, and it only goes once. I knew the answer was 16, so we'll mark that one wrong. C equals, C equals 16. So, you know, like you're doing this, maybe you're doing it in a notebook, I don't know, or you're keeping a record of it, but always, you know, never leave a mistake unchecked on your page, you know, because you might be coming back, you know, like a couple of months later studying for a test or something like that, and next thing you know, bloody hell. Oh, right. No. You got a wrong answer. Okay, so let's do one more. Okay. Yes, I'd like to try another one just to make sure that I've got things right. Okay, 6D equals 150. So 6. Oh, well, we want this in. Ooh. Okay. 6D equals 150. Okay, here we go. 6D equals 150. Right, so we've got 6D, we only want 1D. So divide by 6. What you do to one side, you must do to the other. Okay, the 6's cancel. So that's going to give us D. Now, 6, 2's are 12, and 3 remainder. 6 5's are 30. D equals 25. Now, another thing we can always do is we can go check. If we want to check it, we could go, right, D is 25. 6D equals 150, so 6 times 25 equals 150. Oh yeah, double check, 2 ticks, double check. Quite often, especially if you're in a school situation or something like that, or even if you're in the workplace situation, you are trying to show somebody what you know. You're not sort of trying to prove it to yourself. You're usually trying to show someone else. So make it easy for them and make it clear as to what you've done, and you're trying to show that you know what you're doing. So by doing a check, it shows that you know what you're doing and that you understand things. So remember, like if you're in a test or something like that, that's like game day. It's not practice, it's game day. You got to have your game face on. You got to do your absolute best and show, leave 100% on the field. You don't, you can't afford to be mediocre and leave bits out and do it like that, because, that's not what we do on the game day. We've got to be on the top of our game. So that's why, putting all these little frilly bits in, showing exactly what you've done. One, in a test situation, it shows that you have good knowledge of your topic. And in a workplace situation, it makes it clear to your colleagues exactly what you've done. And like, for instance, here, I should have perhaps written here, and divide both sides by 6. I should have shown that there because, as a lot of the great sportsmen say, you do and practice what you do on game day. So you're practicing for the game. So make sure you've got it all done and right, and you know exactly what you're understanding, and that way you'll do very well. Okay, so in this case here, we've got 25. Nice work. Spot on. You're getting the hang of it now. Okay, I think we'll leave it there. So that's 7:30. Always my designs was always to go just till 7:30. So this is episode 2. I'll do another one tomorrow, just very quietly. The point of these is to discuss and explain and not leave anybody behind. Make sure we're working through. I really like need plenty of examples and things to work with if you want to join in, and feel free to send me things at whatever you want. I'm just trying to oops, it didn't work. I don't know how I thought I could get various pages, but I can't. It would seem. Here it is here. What's happening there? Nope. Don't know. I'll have to work on that. Oh, here we go. Oh, we've got back to the beginning. So yes, that's got my email address on it there. Just remember that we're here. We're going to show you lots of techniques and different things that we can use, apps, calculators, and all that sort of thing, just to try and boost your understanding of maths, boost your confidence as you move forward into more harder and difficult things. So I'm starting off real easy. I'm starting at possibly year 9 level, and I'll sort of maybe get the topics moving forward, but certainly happy to jump ahead. If you've got a problem that you need some help with, we can have a look at it. So yeah, I'm going to end it all there. Thank you so much for watching and commenting, subscribing to my channel, or all of these things. Yeah, bloody marvellous. Good night and good gardening to you all.